So indices, but you might also hear the term exponentials. It means the same thing, right? So syllabus objectives. This is what the syllabus requires you to know. So this is what the PowerPoint would be based on. Use the laws of indices to solve exponential equations with one unknown. Equations reducible to linear and quadratic forms. So by the end of this topic, you'd be able to do this. And once you're able to do this, you're good to go. You see these surds and indices. You wouldn't really see past papers on those, but logs, yeah, you're more likely to come across logs than the surds and indices in a past paper. But all that you would learn here, you might have to apply it to some other question. So not necessarily under this topic. Say you're doing what topic could it come under? I don't know, maybe like with that trigs. You might have to apply these rules, the laws of indices and the rules with surds. You might have to apply them in some other topic. You wouldn't see a question like, hold on, let me just show you something. Like you wouldn't see in your past paper, x to the power 5 multiplied by x to the power 4, simplify that. No, you probably wouldn't see that. You're more likely to see the logs. So that's what I'm trying to say, right? So you might need this knowledge of the laws of indices, answers and all that to answer questions. But I've never seen a past paper where they just flat out give you an exponential and say, simplify this. No, never seen that before. But you never know. They could bring it for you, yeah. So what is an index? Well, index. What are indices? Indices show how many times a number is multiplied by itself. For example, 2 raised to the power of 2, so 2 squared. All that means is I'm multiplying 2 by 2. So 2 squared, hold on, 2 squared. So I'm multiplying 2 by 2, and we know that's 4. This other example, 5 by the power of 3. So 5 cubed. All that means I'm multiplying 5 by itself 3 times. So 5 multiplied by 5 multiplied by 5. That's the purpose of an index. It tells me how many times I'm multiplying a number by itself. So 5 cubed means 5 multiplied by 5 multiplied by 5, which would give me 125. So that's why we could say it's written in the form a n to the power of n, where a is called the base. So a is called the base, and n is called the exponent or the index. Why said indices are also known as exponentials? It's because this, let me just write it over. My mouse is still giving trouble there, so bear with me. A to the power of n, this n is known as an index. My mouse is giving trouble. Index, and the plural of index is indices. That's how they got this word, indices. So n is called an index, but it's also called an exponent. My mouse. Exponent. And that's why indices are also known as exponentials. That's why I said indices, exponentials, they're the same thing. Why? Because an index and an exponent is the same thing. So you good with that so far?
Yes, Miss.
Yeah. Okay. So laws of indices. Once you know all of these laws here, you'd be able to solve any question. So just like we said, they had laws that you had to apply. There's something called laws of indices, and there are 8 laws. So the first one, these are just things you have to remember, right? So a to the power of n multiplied by, a to the power of n multiplied by a to the power of m is the same as a to the power of n plus m. So I need you to pay attention to this. We said that a is called the base. Notice that these have the same base, right? That's something real important that you have to remember, because some people, after they learn the topic later down, they start mixing it up and they might see like a 2 to the power of 3 times 3 to the power of 3 and say, oh, well, that's 6 to the power of 3 plus 3, which is 6. No, that's not how it works. It must be the same base. 2 and 3, they are not the same. These do not have the same bases, and therefore this rule cannot apply here, right? So just remember that. It's always the same base. So instead of having 2 to the power of 3 times 3 to the power of 3, the rule wouldn't apply there. But if I had 2 to the power of 3 multiplied by 2 to the power of 3, the rule would apply here. And according to this rule, a to the power of n multiplied by a to the power of m, all I have to do, I keep my base, so whatever the base is, it remains the same. In this case, 2 is the base, so I put back 2 here. Let me just erase this thing that I had before. And the powers, also known as exponentials or the indices, would add. So the index here is 3, the index here is 3. So what I do, according to this rule, I add the powers, so it's 3 plus 3. And that's why I would have 2 to the power of 6. You understand that? Yes, no?
Yes, miss.
Okay, but you wouldn't leave it like this, because this could be simplified further. 2 to the power of 6 is 64. But I just wanted to show you the rule. So this is how you apply that. Must be the same base. And when they multiply by each other, you have to add the indices. So just remember that. Second rule, it says that a to the power of n divided by, so this one is multiplication, now we divided them, divided by a to the power of m, instead of adding their indices now, what I'm going to do is subtract them. So let me just rewrite this. So a to the power of n divided by a to the power of m. So a n, that's an n, divided by a m. According to this rule, when this happens, remember, same base, these numbers have to be the same. The bases must be the same in order for this rule to apply. If the bases are not the same, this rule will not apply. Okay, I need you to remember that. So a to the power of n, so whatever number raised by whatever power divided by another number. Okay, let me say that. A to the power of n divided by a to the power of m, it's a. So we keep the same base, whatever this number is, we put back that number, and then the indices would subtract. So now let's do an example of that. Say I had base 3 this time, to the power of 4 divided by 3 to the power of 2. Remember, bases must be the same. Okay. And this is that a is called the base. So bases must be the same. In this case, the base is 3 and 3. So okay, now that I know that the bases are the same, I know that I could apply this rule. what does the rule say? When dividing them, I must subtract the indices. So what does that mean for me? This would become 3. You put back the 3 because that's the base. And then you say 4 minus 2, which is equal to 3 to the power of 2. But we don't just leave it like that because we know that 3 to the power of 2 is 9. You good with that?
Okay, you coming up?
Yes, miss.
Next rule. This is a simple one. Anything raised to the power of 0 is always 1. So if I have 2 raised to the power of 0, that's going to give me, let me write that out. 2 to the power of 0 is 1. 16 to the power of 0 is 1. 2,457 to the power of 0 is 1. Okay, anything raised to the power of 0 is 1. So always remember that, right? Whatever number it is, it does not matter. Once it's raised to the power of 0, the answer is going to be 1. And you could just punch that into a calculator if you want to. Any number, it could be a trillion, raised to the power of 0 is going to give you 1. The fourth one. So a to the power of n, and this whole thing multiplied by some other power. So let me do an example for this one. Say I have 4. So 4 is my base, that's a in this case, to the power of 3. So the 3 is n. And then this whole thing raised to another power. My m in this case, I'm going to put it as 2. So 4 raised to the power of 3, whatever number I get there, when I square it, so let me do it now. 4 to the power of 3, that's 64, right? So 4 to the power of 3 is 64. And then 64 squared. I'm just using this example to help you understand it. So 64 squared, that's 4,096, right? According to this rule, this right here is the same as 4 to the power of n multiplied by m. So n in this case is 3, m is 2. 3 times 2, that's 6. So what does this rule tell me? When I punch into my calculator 4 to the power of 6, I'm supposed to get this same answer here, the 4,096. So if you just punch that into a calculator now, you will get 4,096. And that is why they came up with the rule that a to the power of n, and this whole thing raised to another power, is the same as a to the power of n multiplied by m. You good with that?
Yes, miss.
Okay. You're not good with that, please. Let me know. But that's not the only thing though. I want to show you something else. So yeah, we just found out that a to the power of n, and this whole thing raised to another power, m, is a n multiplied by m. But let me show you something else. What color? Let me purple. So this right here, let me erase this again.
Afternoon, miss.
Good afternoon. So this is my example. This is the example from just now. So A is 4, M is 3, and this whole thing raised to the power of 2. What I want to show you is that this is also the same as A, so 4 raised to the power of 2, and this whole thing raised to the power of 3. So all I just did was switch these two numbers. So instead of having 4 cubed and then this whole number raised to the power of 2, I switched the numbers. So now I have 4 squared and whatever number I get there raised to the power of 3. I just want to show you that this is the same thing. So when we put this into the calculator, we got 4,096. And what I'm telling you right now, if you put 4 squared, so 4 squared, that's 16. And then you say 16 to the power of 3, so 16 cubed, you're supposed to get the same answer. If you don't believe me, you can check. I advise you to check it now so you see for yourself that it is actually true. 4 to the power of 3, so 4 cubed, and this answer that I get, square it, I get this. And I'm telling you that this is the same as this. I can switch these numbers if I wanted to. So 4 squared, which is 16, and then 16 cubed would also give me 4,096. So in short, what I'm trying to prove to you is that A, this is the rule, A to some power, so I name that N, and then this whole thing raised to the power of M, this is the same as, so this symbol means equivalent to, right? A to the power of M, and this whole thing raised to the power of N. I just switched the numbers. So, everybody good with that?
Yes, miss.
Okay. Fifth rule. It says that A to the power of minus N is the same as 1 divided by A to the power of N. So let me show you an example. If I had 3 to the power of minus 2, according to this rule, this is going to give me 1, oh gosh, that's a 1, divided by 3 to the power of 2. But of course, we won't just leave it like that because we know 3 to the power of 2 is 9. But I just wanted to show you this part up here. This is the rule. And this is how you would apply that rule. So you good with that? That's rule number 5.
Yes, miss.
Okay. Once you know these rules, you're good to go. 6th rule. It says that A to the power of N divided by M is the same as whatever this M is, root A to the power of N. Examples are always best to show you what this would look like. So say I have, what number? 2, let me just use 2. 2 to the power of a half. So this 1 in my numerator would be N, and then the 2 in my denominator would be M. And according to this rule, this is also equal to, so I put back the root sign, M, which is this denominator right here, goes outside. You put back A is my base, and numerator comes inside. But of course, we know that if I have a root sign and I say it to the 2nd degree, that's the same as just writing the square root, right? So just making that clear. Let me rewrite this. a number. So say I have the square root of 4. Saying the square root of 4 is the same as saying this to the second degree divided by 4. So I just wanted to show you that. So this, what I have here, to the second degree, I could just remove this sign right there. It means the same as the square root. You understand what I'm trying to say? I think you would know this, but just in case you didn't know. Yes, no?
Yes, miss.
Okay. So that's that. If I had, let me do another example. Same two, but raised to the power of 2 down. According to this rule, you put the symbol 2 comes in here. I'm looking at this ruler. You put the 3 outside, and then 2 to the power of 1. Oh, I didn't have that rule. There's another rule. Anything raised to the power of 1 is itself. So I have a to the power of 1. The answer is a, right? 2 to the power of 1, the answer would give me 2. I didn't put that rule, but I would. I didn't put that rule, but I would include it. Anything raised to the power of 1 is itself. And that's why 2 raised to the power of 1 is just going to give me back 2. Seventh rule. This is where the basis change. So from number 1 to 6, you just saw a. Oh, for the people who came in late, let me just show you. This is what the this is the general form, the exponential form, where a is called the base and n is called the index, or you might see the exponent, or you might even see power, right? So from 1 to 6, they all had the same basis. So I need you to remember that. These rules from 1 to 6, they only apply if the bases are the same. For 7 and 8, I want you to notice that I don't just have A, I have A and I have B. So what does that mean? These bases are not the same. Example, looking at number 7. It says that AB, so A multiplied by B, whatever number that gives me raised to the power of n is the same as A raised to the power of n multiplied by B raised to the power of n. So what would that look like exactly? If I had 2 times 3 to the power of 2. According to this rule, these are 2 different bases, right? According to this rule, this is supposed to give me 2 raised to the power of 2 multiplied by 3 raised to the power of 2. That's what this rule is saying. 2 numbers raised to a power is equal to A to the power of n multiplied by B to the power of n. Everybody go to that? Yes, no?
Yes, miss.
All I did was follow the rule, huh? Let me just prove this to you. 2 times 3, that's 6. 2 squared is 4 multiplied by 3 squared, that's 9. We know that 6 squared, that's 36. And according to this rule, 6 squared is the same as 4 multiplied by 9. 6 squared is 36. And 4 times 9 is also 36. So that's how we know that this rule is actually correct. Right? So just to show you that. Last rule. Two different bases again. So say I have 2 divided by 3, and this whole thing raised to the power of 5. According to this rule, this would be the same as 2 raised to the power of 5 divided by 3, also raised to the power of 5. So if you just punch out into a calculator, let me do it now to prove to you that the rule is actually correct. So when I put this into the calculator, the answer is 32, 1, 2, 43. And now this one. 2 raised to the power of 5, that's 32. And 3 to the power of 5, 243. That's just to prove to you that the rules are actually correct. So 2/3 raised to the power of 5 is the same as 2 raised to the power of 5 divided by 3 raised to the power of 5. So everybody good with these rules? Yes, no?
Yes, miss.
Okay. These are just rules you would have to memorize, but it's also important to understand why they're correct. So if you punch in any value, just like I did, like I use random values to show you that the rule is actually correct. That's just to help with your understanding. Once you know these rules, you're good to go. Let's practice them now. I'll do the first one with you, and then I'll leave you to do 2 to 6. So no, not red. I could try to use red for the formulas. No, come on. Okay. X to the power of 5 multiplied by x to the power of 4. I would have to leave the screen up so you could see the rules just until you do them. The rule that would apply here is the first one that we learned. So a to the power of n multiplied by a to the power of m is the same as a to the power of n plus m. So that's the rule that we're looking at for this one. Notice the bases are the same. The bases, in this case, they're both x. Let me just put this for the people who came in late. Oh, come on, come on. Wait, a is the base. N is the index. Just for the people who came in late. That's why I could just look at this, eyeball this, and say, okay, the both of them have the base x. So I could apply this rule. So according to this rule, x to the power of 5 multiplied by x to the power of 4, that's supposed to give me x to the power of 5 plus 4. But we don't just leave it like that, of course, because we know that 5 plus 4 gives me 9. And that's why the answer for this one would be x to the power of 9. Move on. At the indices. So everybody go to this?
Yes, miss.
Yes, miss.
Okay. You just have to learn off the rules when you get in it. You can answer any question you have to once you know those rules. Now it's your turn to practice this. Oh gosh, I have a little over a minute. Okay, do this. Okay, so do numbers 2 to 6 for me. Remember, you could send me your answers on Zoom. So just send me what you get. Or on WhatsApp, you could take a picture of what you have, like your whole working and all that, for me to check it, and you could send it to me. Right? So do number 2 to 6, and then when you finish with that, we will go through all of them. Okay, you need to leave and rejoin because we have less than a minute. But start working on those.
Yeah, they'll come on.